Hi and Assalamualaikum. Today our group gonna present you a lot of information on X-ray spectroscopy. First and foremost, let me introduce you to our four beautiful group members. Dini Nazifa binti Mohammad Rosidi, Allia binti Maha, Iffah binti Mohammad Solan, and kali ini Asmetta anak perempuan Jeevaraj.
X-ray spectroscopy uses X-ray excitation in order to characterize polymer. It produces qualitative results regarding the composition of the tested compound. There are two types of X-ray spectroscopy, which are energy dispersive X-ray spectroscopy and wavelength dispersive X-ray spectroscopy. The first type consists of a semiconductor detector which measures the energy of incoming photons. And for the second type, a single crystal diffracts the photons according to Bragg's law, which are then collected by a detector.
So, what is the Bragg's law? Bragg's law states that the X-rays reflected from different parallel planes of a crystal interfere constructively when the path difference is integral multiple of the wavelength X-rays. As you can see in the slide, the Bragg's law gives n lambda equals to 2d sine theta. Here, do you want to know a fun fact? The Braggs were awarded the Nobel Prize in Physics in 1915 for their work in determining crystal structures that they begin with NaCl, ZnS, and diamond.
How does X-ray diffractometers work? First, we're going to look at the components of X-ray diffractometers. It consists of three components, which are X-ray tube or X-ray source, sample holder, and detector. We're going to look at all of these one by one. The first one is X-ray tube or X-ray source. Inside the X-ray tube, electrons are generated at the cathode part. Electrons are accelerated from cathode to anode through high voltage, which is around 30 to 150 kilovolts. During this process, most of the energy will be released as heat. After it hits the anode part, X-ray will be generated. This is due to the transition of electrons from higher energy state to lower energy state. There are many sample holder options to hold all kinds of sample and meet people's requirement. One of the example is glass slide. Glass slide is used to ensure that the sample is flat and easy to be examined. Sample holder has a press ring to fix the slide. This is to ensure that the glass slide will not move too much while the polymer sample is being analyzed. It is usually made up of single crystal silicon. The next one is detector. Photographic film serves as a detector. The film is placed around the sample as a circle and records the diffracted X-ray beam from the polymer sample that is being analyzed.
Let's look at the diagram of X-ray diffractometer. It consists of three basic elements, which are X-ray diffraction experiments are routinely carried out with either single crystal X-ray diffractometer or powder X-ray diffractometer. For the process, X-ray beams are generated on the X-ray tube. When it hits the sample, which in crystal or powder form, it diffracts in a pattern characteristic of the structure. The detector that is made of phosphor screen will then record the signal obtained and provides a diffraction pattern plots intensity against the angle of the detector.
Let's continue in what is the application of X-ray spectroscopy. X-ray diffraction XRD applications, determination of lattice parameters, the determination of grain size in polycrystalline blocks, nanomaterials that more detail on phase composition, crystallite size and shape, lattice distortion and faulting, composition variations concentration, and lastly, new variation development. So let's continue on X-ray diffraction limitation. cannot identify amorphous materials, no depth profile information, and lastly, the minimum spot size of 50 micrometer. Let's continue on our last subtopic. What is the example for X-ray spectroscopy? X-ray photoelectric spectroscopy is one of the examples for X-ray spectroscopy. As shown in the figure in the slide, this is the basic components of a monochromatic X-ray photoelectric system. X-ray photoelectric spectroscopy is a surface-sensitive quantitative spectroscopy technique based on the photoelectric effect. The objective is to identify the elemental composition. It is applied to study chemical processes in the materials in their as received stage or after cleavage, scraping, exposure to heat, reactive gases or solutions, ultraviolet light, or during ion implantation. The uses is used in line profiling of the elemental across the surface or in depth profiling when paired with ion beam etching. That's all from us. We hope you guys enjoyed our video and got a lot of information. Thank you. See you soon.